On Halloween night, some treats in the night sky while we wait for an expected big event. And we're going to use the word zombies. Welcome back to Techstination. I'm Fred Fishkin. Joining us from NASA is astrophysicist Padi Boyd. Hi, Padi.
Hey, thanks for having me, and I'm really excited to talk about zombie stars.
So, the anticipation has been building for the awakening of what some are calling a zombie star. Explain that terminology for us.
So, a zombie star is a nickname for this particular event that we're waiting for, which is called a recurrent nova. So, recurrent means it's going to happen and it's happened in the past. And a nova is an explosion on the surface of an otherwise dead star. And when that explosion happens, we will see the star as a night sky object, a star in our sky. So, instead of being dead, it will for a little while be an undead star. Well, hence the nickname zombie star.
Why such interest in this? And I think it's called the T Corona Borealis.
Yes. So for one thing, yes, it's star number letter T in the Corona Borealis constellation. That's basically its catalog number. Why we're interested in this one in particular is because it's 3,000 light years away, which is actually kind of a close neighbor when it comes for things like recurrent novae. It's unusually close, which means that we can observe it with all of our telescopes on the ground and in space for weeks or even months or continuously in this case. So we're really getting excited to measure its brightness as a function of time at all wavelengths.
And what can be learned from it? Are there other things besides just seeing how bright it is?
Absolutely. So the brightness is just a measurement, but we're going to learn so much from all of our measurements, not just the brightness, but also its spectrum. Well, how does the light come from this system as a function of time to our telescopes? What we're hoping to learn is how material is distributed throughout the galaxy. Things like carbon, nitrogen, and oxygen, these elements are created in stellar explosions like this nova. And when the explosion happens, that material gets spewed out into the local area. You see some beautiful images from Hubble and other telescopes showing us how that material, like the carbon and the oxygen, is being distributed. These are the building blocks of life. They're the building blocks of planets. And learning how that material is distributed throughout the galaxy is a really important piece of the puzzle of why are we here?
Well, how do we know for sure that this is going to happen? It's not keeping to our timetable, I don't think. It was expected, I think, by the end of September, perhaps. But how do we know?
So it's very hard to predict accurately such an event. There's a large what we call error bar, a range of dates when it can happen. We've observed the last two eruptions very well in the optical with ground-based telescopes. So you see here how the brightness changes with time. The last time this exploded was in 1946. Before that, about 9 months before that, we saw the light actually dim. We call that a pre-nova dip. We're seeing that in this system now, even though we're only 78 years from the last explosion. So it could have happened as recently as 9 months after the beginning of that pre-explosion dip was observed, but it can also happen as late as 80 years after the last explosion, which would put it all the way in 2026. So we're anticipating it sometime soon now. The more time that goes by, the more likely it is to go off.
How visible is this going to be? Do we know? Do we have an idea?
So this will be the first time that we're really going to be able to track its brightness on very short timescales. But the last two times that the nova went off, it was observed and it got to what we call magnitude 2.5 or so. That's just a way that we measure brightness of stars. And in both of those cases, it got bright enough to be seen by the naked eye in the night sky. So it will be about as bright as the stars that you see in the recognizable constellations for a couple days.
And doing so, it will be a couple of days. It's not going to be like, hey, you weren't looking, you missed it.
You should have a couple days to check it out, maybe even up to a week if you've got very dark skies, if you're training your eyes to find new objects. But after that, it will dim, it'll get dimmer and dimmer with time. So if you get your binoculars out, you should be able to see it for quite a bit longer
Terrific.
for a telescope.
Before we go, Patty, you and I have a connection. We are both from Perth Amboy, New Jersey.
Awesome. Go Perth Amboy. Were you born there?
Yeah, I was born there, and I understand you also love to sing. So, real quick,
Mhm.
tell me about the decision to go into science instead of the arts.
Well, that was a hard decision. I love singing about science as well. I just loved the universe so much and everything in it when I was making a decision like that. But I kept the singing up, and I write songs about things out there in space, a project called Astro Capella with a six-voice a cappella group called the Chromatics. So I get to do both.
Can we find that online?
You can absolutely find Chromatics Astro Capella songs online. They come, each one of them, with a lesson plan and all kinds of information about how we know what we know from telescopes on the ground and space about what we're singing.
Math, science, history, unraveling the mystery that all started with a big bang. Hey!
And where do we go to follow what's going to happen with the zombie star?
The best place to start is at NASA Universe on all social media platforms. NASA is following this with great anticipation and enthusiasm. We will make sure that we are explaining what's happening in real time as soon as this nova goes off.
Padi Boyd, thank you so much for spending time with us.
My pleasure. Thanks for having me.